Welcome to Monkey Physics IIT JEE NEET Foundations.
Yeah. So let's go with one more example. Now here vehicle is moving with 4 meters per second. It is maintaining the acceleration of 5 meters per second square. Of course, a little bit change we can observe in this numerical. It starts from rest. Let us take. It starts from rest and maintaining the acceleration of 5 meters per second square. Now after some time has elapsed, now it has covered the distances. Now what is the time? Time t is equivalent to 0 and the t equivalent to here it is given 4 seconds. Now they are asking us what are the possible things they can ask in this question. Suppose if the position of the object is it's a 10 meters initial, that is initial position. Now after traveling the displacement and what could be the final position. Now what are all the possible questions we can frame in this description? Look at here. Now the object starts from rest, maintaining the constant acceleration. It has made its journey for 4 seconds. When it initially starts from x equivalent, position 10 meters. Now they are asking question number 1. What could be this velocity? Question number 2. What could be the displacement? Question number 3. What is this position? Final position. Okay. Now I am giving you find velocity. Second one, displacement. Third one, final position. This is with respect to t equivalent to 4 seconds. All these things. Hope it's clear. Now the fourth one. Now what is the displacement in the second, or else we can calculate displacement in the first second, displacement in the second, displacement in the third second. You should find it out. Total journey is given as 4 seconds. Na? So what is the displacement in the fourth second? Yeah. Now after finding this, we can write the ratio of displacement in the first second is 2. Displacement in the second is 2. Displacement in the third second is 2. Displacement in the fourth second. That is also we can. Now let's see here. Solution. Now what is initial velocity given? Starts from rest. Na? Initial velocity is 0. What is the acceleration given? 5 meters per second square. And what is the velocity they ask us? And what is the time given? 4 seconds. First let us focus on V is equivalent to U plus A. V is equivalent to U, 0, A, 5, T, 4. So what happened to this? 20 meters per second. So velocity after 4 seconds is 20 meters per second. Now coming back to displacement, we use S is equivalent to ut plus half at square. S is equivalent, of course, it starts from rest initial velocity. Hope it's clear, right? So half A is nothing but 5. T square means 4 square. Time is given as 4 seconds. Now. So S is equivalent to half into 5 into, it's 16. So S is equivalent to 16, 2 it goes 8 times. So 8 5s are 40 meters. Yeah, this 2 in this 8 times. So 8 5s are 40. Now the third one, what is the position? We know clearly. What is the displacement? Final position minus initial position. Of course, displacement we got it as 40 meters, right? But what about the final position? We don't know. But initial position is given. How much is the initial position? 10. Now final position is nothing but 40 plus 10. So final position is 50 meters. 50 meters. Hope it's clear, all of you, right? Then next, fourth one. What is the fourth one? What is the displacement? We all know displacement in the nth second formula, u plus a by 2 into 2n minus 1, right? We should use this formula. And we should be, when you are clear about the concepts, then you come to know which formula to be used based on the situation. So it's not like remember the formula and substitute in the formula. So if you don't know which formula to be used, then what is the need of remembering the formula, right? So first you should be clear about the concepts. Then only you come to know that for the given situation, which formula is suitable. Then first, after knowing which formula is suitable, then only you can substitute in the formula. Okay. So there is no, of course, it is a additional advantage only to remember all the formulas. Yeah. Now, first is nothing but initial velocity is 0. Na? Acceleration is 5 by 2. And 2 into first one, 1 minus 1. N is equivalent to 1. So 5 by 2, it's 1. It's nothing but, what is that? 2.5 meters. Then S second I am taking again, this is 0, a by 2, that is 5 by 2. 2 into, in place of n, we can keep 1, so 2. So 5 by 2 into 3. How much is that? 15 by 2. It's a 7.5 meters. Now S third displacement in the third second, it's a 5 by 2 into 2 into 3 minus 1. So it's a 5 by 2 into, it's a 6 minus 1, 5. It's a 25 by 2. It's a 12.5 meters. S fourth is equivalent to again a by 2 because initial velocity is 0. Okay, a by 2. So 2n, 2 into 4 minus 1. So it's a 5 by 2, 8 minus 1. So 5 by 2 into 7. It is a 35 by 2. It's a, yeah, how much is that? 17.5 meters. Okay, yeah. Now if you observe the last one, S first is to S second is to S third is to S fourth they are asking. Now S first to 2.5, isn't it? Is to next 7.5 is to next 12.5 is to next one 17.5. So what is the ratio you're going to take? This is 1 is to 3 is to 5 is to, it's a 7. So it is a ratio of odd integers if you observe one thing. So this ratio of odd integers is valid. When it is valid, there must be two conditions to validate this. So condition number 1, the initial velocity must be 0. That is what? Initial velocity must be 0. That is a condition number 1. And condition number 2, acceleration should be constant. If initial velocity is equivalent to 0, okay, and acceleration is equivalent to constant, then how do you write it? The displacement in the nth second, look at here. S nth is directly proportional. What I am writing here? It is 0. Now in a is constant. Of course, a by 2, constant by constant, it's a constant. Now it is proportional to 2n minus 1. Displacement in the nth second is proportional to 2n minus 1. Please take this point into your note. Yeah. So now, first to second, if you substitute 2n minus 1, so it will directly proportional to 2n minus 1. N represents the number of the second, right? So n, first one, n, 2 minus 1, 1 is 2. 2 if you give 4 minus 1, 3. 3 if you give 6 minus 1, 5. 4 if you give 8 minus 1, 7. So this is valid for the ratio of the displacements in nth seconds when initial velocity is 0 and acceleration is constant. Yeah, this is a valid point. You please remember that. Yeah, thank you.